All right, let's just jump right into this explainer. Today, we're going to demystify the day-to-day operational monitoring and maintenance of Junos OS devices. Because, let's be real, if you work with networks, you know that keeping a system running smoothly doesn't just happen by magic. It takes constant vigilance and a rock-solid diagnostic toolkit. So, let's figure out exactly how to manage these incredibly powerful systems. I want you to imagine you're unboxing a brand new Juniper Networks device. You've got it racked, it's cabled up, and you've just flipped the power switch. The fans roar to life, the lights start blinking, but, well, what exactly needs to happen next to actually bring it to life? How do we take it from a totally blank slate to a fully operational, monitored, and maintained network node? Well, to answer that, we are going to follow the administrator's journey. We'll kick things off with first access and root passwords, then peek under the hood at the core Junos OS processes. From there, we'll dive into monitoring network device health, troubleshooting interface traffic errors, using essential network diagnostic tools, and finally, system upgrades and maintenance. Okay, Section 1, First Access and Root Passwords. So, when you first power on your device, Junos OS automatically boots up. Now, a quick heads up. Remote management access, like Telnet or SSH, is totally disabled by default for security reasons. So you'll need to execute these 4 basic steps to get that initial access. First, you connect your laptop directly to the console port, power it on, and wait for the boot process to finish. Then, at the prompt, you literally just log in as the user root. Keep in mind, initially, this actually requires no password. Oh, and a quick pro tip. If you ever forget your configured password down the line, you'd perform a root password recovery by intentionally interrupting this very boot process. Anyway, once you're in, just type CLI to fire up the command line interface. Now, I really want to emphasize the console port here. The official documentation specifically reminds us to check the hardware guide for connection instructions, and there's a good reason for that. Why so much focus on the console port? Because it gives you persistent direct access to the device. You can usually access this connection even if the primary network has completely cratered. It is without a doubt your absolute lifeline when things go south. Moving on to Section 2, Core Junos OS Processes. Once you're inside the CLI, you basically have the keys to the kingdom. But before we start monitoring, we kind of need to know what's actually running in the background. Think of the init process as your master watchdog. It's the very first thing to wake up when the device boots, and it immediately starts supervising absolutely everything else. If any other software process suddenly crashes or just fails to start, the init process steps right in, tries to restart it a few times, and logs the failure so you can dig into it later. Right beneath that init watchdog, you've got a few specialized processes that act like the vital organs of your device. The management process, or MGD, is what you're actually interacting with when you type in user commands. It handles the configuration database and tells the other processes when you've committed a new config. Then there's the interface process, DSCD, which handles the physical side of your network links, like encapsulation and keep alive timers. Finally, the chassis process, ChassisD, manages the physical properties of the device itself, including any conditions that might trigger system alarms. All right, Section 3, Monitoring Network Device Health. Let's see how to actually check on those vital organs. In Junos OS, your main tools for checking device health are your show commands and your monitor commands. It's really helpful to think of show commands as checking a patient's static vital signs. You type something like show system uptime, and boom, you get a snapshot of the current state at that exact second. On the flip side, monitor commands are much more like a live streaming EKG. If you enter monitor start messages, it's literally going to stream the real-time system log right to your terminal screen until you explicitly tell it to stop. And for those of you coming from a Cisco background, don't worry. Learning Junos is really just a matter of mapping your vocabulary. For example, what you'd normally call show clock is simply show system uptime in Junos. Need to check your hardware inventory? Forget show inventory, you're going to use show chassis hardware. And that real-time log monitoring we were just talking about, your old friend terminal monitor is now monitor start messages. Having this mental cheat sheet makes the transition incredibly smooth. Section 4, Troubleshooting Interface Traffic Errors. Because, let's be honest, eventually things will break. Packets will drop, traffic will fail, and when that happens, you need to know exactly where to look. When you're using those show commands to diagnose dropped traffic, you're usually hunting for a few usual suspects. The documentation points out that traffic loss usually comes down to overloaded system conditions, strict policies restricting bandwidth, broader network outages, or sometimes just simple physical cable faults. You really have to rule these out first. It proves that no, it's actually not always the firewall's fault. Sometimes it really is just a bad cable. The real key here is understanding the specific terminology popping up in your interface statistics logs. You might spot a counter for framing errors, meaning packets are arriving with invalid checksums. Or you might see runts. Runts are exactly what they sound like, frames received that are simply smaller than the acceptable runt threshold. Nailing down these specific error types tells you exactly what kind of damage your packets are taking on the wire. You also want to watch your error thresholds like a hawk. For instance, if you see any number other than 0 for FIFO errors in the received direction, that is a massive red flag. It usually means the ASIC on your physical interface card is malfunctioning. Carrier transitions are another huge tell. That counter tracks how many times the interface has gone from down to up, and it really shouldn't be incrementing quickly. If it's jumping up, say, every 10 seconds, you are almost certainly dealing with a loose cable, a far-end system continuously rebooting, or a bad interface card. And if you see resource errors, that usually points to oversubscription drops right on the packet forwarding engine. Moving on to Section 5, Essential Network Diagnostic Tools. To actually isolate those hardware and routing bugs, you can't just passively read logs all day. You need to get active. Instead of just staring at error counters, you use tools to actively probe the network. You use traceroute to trace the suspect's path hop by hop to see exactly where the connection drops dead. You can use ping rapid to just flood immediate echo requests and test your raw connectivity. You've also got commands like show ARP to pull up your ARP table, or show lldp neighbors to find adjacent devices connected directly to you. These are the tools you use to actively interrogate the network and prove your troubleshooting theories. Which brings us to our final section, system upgrades and maintenance. You've monitored the system, you've troubleshooted the errors, and now it is time to keep the software up to date. When you are ready to install a software update package, the specific CLI syntax you need is request system software add package. Now, think back to what we talked about at the very beginning of this explainer, the console port. The documentation strongly recommends doing all Junos OS upgrades over that persistent console port connection. If you try to run an upgrade over SSH or Telnet, your network connection will likely get interrupted during the process, and you could miss critical status updates or error messages. Honestly, just don't risk it. And just like with the monitoring commands, your routine maintenance tasks map really nicely from other systems. Need to reboot the system? What you probably know as a reload in Cisco iOS is simply request system reboot in Junos. Want to undo a change and revert your configuration? Rollback followed by the version number is your best friend. But I have to say, out of all the maintenance commands, this next one is arguably the most powerful tool in your entire Junos OS arsenal, commit confirmed. When you type commit confirmed followed by a number of minutes, it applies your new config with a built-in rollback timer. If you don't follow up with a second standard commit before that timer runs out, the device automatically rolls itself back to the previous configuration. It's an absolute lifesaver. If you apply a bad config that accidentally locks you out remotely, the system just fixes itself. It's basically the Junos equivalent of scheduling a reload in command before making a really risky change. So we've covered a ton of ground today. From that very first root login on the console port, straight through the core processes, and deep into the weeds of error monitoring and software upgrades. But I want to leave you with this final thought. Your network is constantly generating data, logs, and statistics. It is always talking. Mastering these monitoring and diagnostic tools is simply how you learn to listen, and listening is how you keep your systems resilient, healthy, and high-performing. Thanks for hanging out with me for this explainer. Keep learning and, seriously, keep listening to your network.